Record. Hey, here, Mr. Sadaf Sapix, and this is our new mentoring gift this video with precious neurolinguist Ryan Rhodes from Rutgers University Center for Cognitive Science, New Jersey. For gifted learners in this channel, Aristotle Learning. Today, we will talk on teaching and research fields of Mr. Ross, and finally, mentoring. Normally, I always talk on this channel, but for a difference, in this video, I will only ask questions and listen to Dr. Rhodes. Let's begin. Firstly, in your teaching fields, from EEG. EEG or electrosonography is a tool that allows researchers to observe brain activity. Can you introduce EEG structurally?
Yeah, so if we want to talk about the structure of EEG, it's a pretty simple concept. It's you put electrodes that can measure electrical signals onto a person's head, and it's totally non-invasive, right? You just have something sitting on top of the head like a cap, and you can measure the electrical signals generated by the neurons in your brain. Because the neurons are not actually, the way that neurons are connected to each other, they have little synapses, which are little gaps. And so some of these synapses are actually transmitting electricity across space, and that it allows electricity to bleed out from your brain and emanate all the way up to your scalp. It passes through, your skin and your hair and all that, and we can measure it from outside your head. So we use this non-invasive technology to measure brain activity, and it lets us do some interesting things. One, you can tell when certain things are happening in the brain. You can look at brain response to specific kinds of things. It lets you tell maybe if the brain can recognize the difference between two kinds of things. What it can't tell you is it can't tell you exactly where the signals are coming from. So a lot of times people are interested in what part of the brain is doing something. Say, well, not usually what we do with EEG. There are some ways to approximate that if you collect enough data, but usually we don't ask those kinds of questions. We ask questions about when things are happening, about timing, and we ask questions about sort of like what is happening, what kind of processes are happening in the brain in response to some specific kinds of input or stimuli.
Okay. After the understanding the structural basis of EEG, it's important to delve into its operational aspects, I think. Can you explain the functionality of EEG? Here, our focus shifts from the physical components to how EEG functions to monitor and record brain activity. Your turn.
Yeah, I think usually when people first think of EEG, they think of clinical application. I know my students, that's always what they say. They say, oh yeah, can't you use EEG for things like sleep study or epilepsy? And so yes, there are maybe cases where you go to a hospital or a doctor and they use EEG to diagnose something. My mom is narcoleptic, so she's had a lot of sleep studies done where they go and they put EEG and they let her fall asleep and they measure the brain activity during that process. So you can use it for diagnostic reasons like that. But as researchers, we're interested in using EEG for a different purpose. We're trying to ask questions about things like, I want to know, well, what kinds of things can people learn? And sometimes the best way to measure if someone has learned something is to measure their brain response to a certain kind of stimulus. So right now we're doing a study where we're trying to figure out if people we have English speakers who have never been exposed to Arabic, and we say, Arabic has these interesting sounds that English does not have, that use a part of the vocal anatomy that English speakers have never used, like a muscle you've never moved before, the epiglottis. And we want to know if we can train people to recognize those sounds they've never heard before, sounds they've never made before, using a part of their muscles that they've never used before. And one of the ways you can assess whether they've acquired a sensitivity to those sounds is to measure their brain activity when they hear the sounds, because there's a certain kind of brain response you expect when someone hears a sound that they recognize or when someone hears something they don't recognize. And so we're using that brain activity as a way of getting at has your brain sort of acquired the distinction to recognize this unfamiliar sound.
Okay, sure. Our third question. Prior to the development of modern neuroscience tools like EEG, our understanding of the brain was quite limited. How did we know about the brain when there was no EEG, and what are the current alternatives of it?
It depends how far back you want to go. Modern EEG I think was first applied to human beings. I want to say 1929,
Hmm.
um, or was invented in 1929. So it's it's just a 20th century technology. Before the 20th century, in the 1800s, you have people like Paul Broca, Carl Wernicke, who are the pioneers of of human neuroscience or of linguistic neuroscience, right? Neurolinguistics, because they were neurosurgeons and did various other things, but they would examine patients. They were doctors. They would sometimes have patients who had brain damage, and they noticed that some of these patients who had brain damage, they had very, very specific kinds of problems. Like they either couldn't speak or they could speak, but what they said wasn't making a lot of sense. One patient from Paul Broca could only say a single syllable. He said ton, 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 ton. And this is very interesting that they have, this very specific behavior. And then the question was like, well, what's causing that? And they thought it must be something to do with the brain. So after those patients died, they would do an autopsy on the body, and then they would look at the brain and see what part of the brain had been damaged. And that's where we started to figure out what parts of the brain are important for for like producing and comprehending language by looking at people who have deficits while they're alive, and then looking at what their brain looks like after they die. Not the best process, right? Because you have to sort of wait for a person to die before you can actually find out what went wrong, and you really can't collect any more data after that because they're no
Hmm.
longer alive. So that's like the earliest uh, technique that existed for figuring this out, and we still use, or we still, I wouldn't say we still use the technique. We still study aphasia. We still study brain damage and disorders and things to try to figure out how the mind works. But we have better tools for figuring out what's going on in the brain. We can test people while they're alive now. And if you want to like, what's a better alternative to EEG that can answer similar questions? MEG is nice because it's sort of the sister technology to
Hmm.
EEG, where you're measuring magnetic fields instead of electrical impulses. And that's nice because magnetic fields can pass through, your bone and skin and everything without diminishing. And you can use it. So that's one thing that's nice, but you can also use it to figure out where the signals are coming from with a lot more accuracy.
Hmm.
And the technique that I think is like the most, that does the most, that's very similar to EEG, but tells us an awful lot about the brain is things like electrocorticography, deeply implanted electrodes, where you can put electrodes instead of sitting on top of the scalp, you can put them directly into the brain. The downside of this is that you can only do this for people who are already getting brain surgery. You can't like
Hmm.
volunteer for this. You couldn't show up and say like, "Oh yeah, I'm healthy," can it? But yeah, you cut me open anyways. I want to see what's going on in there. For ethical reasons, you can only do it if people are already getting brain surgery. So it's pretty limited population for that stuff.
Hmm.
But that stuff's really cool because you can tell not just exactly when stuff is happening, but exactly where it's happening. And actually, the spatial resolution for that stuff is even better than MRI. You can get very, very precise. And there's some really interesting research coming out right now from this technique.
Hmm. Okay, sir. And we are coming to questions from cognitive science. Cognitive science intersects various fields, such as neuroscience, psychology, and psychiatry, etc., each contributing uniquely to our understanding of the mind. Can you isolate cognitive science from these fields with an absolute definition? This question challenges the definition of cognitive science as distinct from related disciplines, aiming to clarify its unique scope and focus. Your turn.
It's really hard to give an absolute definition for cognitive science. One, because I think there's a lot of
Mhm.
disagreement internally about exactly what the scope of cognitive science should be, and there are some different approaches. There's a lot of debate internally in cog sci. The other is that the definition is going to be kind of relative. So cog sci is the intersection of a lot of fields. It's not just psychology and neuroscience, but it's also obviously linguistics. I do linguistics, but it also intersects with things like anthropology and philosophy and computer science. And what is it that separates it from all those fields? The thing that separates cognitive science from all of these other fields that it's sort of composed of is that cognitive science is dedicated to a specific sort of narrow class of questions about the mind and how the mind works. So there's a lot of stuff that you can do in psychology, right? Like you mentioned psychiatry. Psychiatry is a branch of psychology that deals with the brain, but it deals specifically with disorders. But the object of study in psychiatry and the purpose of psychiatry is not just to understand how the mind works, but it's to understand how the mind works so that you can
Mhm.
heal people, so that you can help people, so that you can, maybe innovate therapies or interventions that will help people. And neuroscience too is really broad, right? Because it's not just studying how the brain enables you to do things that we can think of as cognitively interesting, like memory and perception stuff, but also there's like systems neuroscience. There's a lot of labs where they're looking at just the structure of neurons and things like that, which could potentially be meaningful to cognitive scientists, but are not really our primary focus. Our primary focus is about how the mind works and how it is that we are able to do things like reason and understand language and navigate the world and things like that. So it's very broad. And also, we're pulling from computer science, partly for computational methods, but also because we're really interested in AI, because of the possibility that AI might constitute its own kind of mind. We're interested in anthropology. We take data from anthropologists. We want to know how what human mind and human thinking looks like across cultures. Because if you only ever look at one culture, you're going to miss a lot, right? There's a lot of different ways that people think, different ways that people solve cognitive problems, like navigation. People do very, very differently in different cultures. So that's also really important.
What's the difference between mind and cognition? Can you explain briefly?
Yeah, so we think the mind is a hard thing to define because there's a lot of disagreement about what it is. Some philosophers and some neuroscientists deny the existence of something like a mind at all. They say mind is just another word for brain. This is one of the things that sets cognitive science apart from other fields. We say we think that there's a thing, we call it the mind. We think that it is at least conceptually distinct from the brain. Some people say we have mantras like the mind is what the brain does. That's one way of putting it. In some sense, maybe cognition is sort of equivalent to the mind in the sense that like, well, the cognition is what the mind sort of does. It is the activity of the mind. Cognition is the ability to do all of these things like language and perception and memory and whatnot. And all of those things maybe together constitute a mind. But the definition of a mind is very nebulous and it is constantly debated. We have not settled this question of what constitutes a mind. This is why we're always arguing about whether some artificially intelligent system, like, ooh, does that have a mind? Well, we don't know because we never fully agreed on what a definition of a mind actually is.
Given the evolving nature of scientific inquiry, certain topics gain prominence based on contemporary challenges and advancements. What topics or questions do you think will be trending in cognitive science, certainly, and in future? I will learn hot topics to spark gifted learners.
I mean, absolutely. The hot topic right now is AI, and specifically it's LLMs, it's large language models, and there are a lot of really interesting questions about large language models. It's really, as a linguist, I'm like, this has really torn apart the field of linguistics in the last couple of years. These debates about LLMs, but these are big questions about can an LLM in principle serve as a viable model for human cognition? How similar is it to what a human mind is doing? Do we learn in the same way that these things learn? And there are people who are really pro on this side, and there are people who are really anti. I'm kind of on the anti side. I don't think that it's a very good model for human cognition. And I suspect that we're going to hit a wall at some point, and we're probably going to have to reevaluate and find a way to integrate symbolic cognition back into AI systems eventually. Gary Marcus is always talking about this, and I think I broadly agree. I think he's probably right. But I think this is the big topic right now. I think it's going to be the big topic for a while. There's some really wild stuff that people are publishing on these models like ChatGPT, saying, it looks like maybe functionally what ChatGPT does is it was trained on a huge amount of text, huge corpus of text. And one of the interesting questions that people are asking is, how much can you learn about the world from just doing computations over text? And the particular kind of computations it does is it's basically just correlating which words go with what other words, doing these sort of create these vector representations that encode word meaning based on what kinds of words co-occur. And it thinks like that's an odd way to represent language. I don't know if humans are representing language that way. But how much can you do with that? How much can that explain? And some people say, like, well, you can get some surprising things out of it. Suppose you take that model, the language model, and you just plug it into some kind of robotic system that has a body. Will it understand enough about physics from everything that it's read, all of the language training data? Will it understand enough physics to be able to navigate an environment? And some people say, like, yes, it can do that, which I think is just wild. One thing I think it shows is that I think there is a lot of hidden information in the corpus of
Mhm.
of a spoken language or of a written language. Like when we communicate with each other, we actually are communicating a lot of information about the world, and maybe that information is extractable in this way, or maybe some of it is. I don't know. It's interesting.
Yes. Uh, Linguistic is a broad field that covers the structural and functional aspects of language through various elements. We know that language has five main elements: phonology, morphology, syntax, semantics, and pragmatics. What problems are currently being worked on in this field, and what problems will gain importance in future? Same previous question.
So this is a good question. So I think generally, if we talk about theoretical linguistics, one of the things that's kind of always going on
Mhm,
is there's always some kind of dominant model or paradigm,
mhm,
and people will work with that paradigm to see like can it explain the languages that we observe, and you sort of work with it until you break it, until it no longer functions. You find something like, well, we can't explain how this works in the model. So this is always a part of the project, is like how much can we do with this until it fails. And with that in mind, I think some of the interesting things that are happening right now is there are a lot of people, maybe not a lot of people, but there's sort of
mhm,
a new emerging kind of popular area to work in, is working at the interfaces, what linguists call the interfaces. So I think of people like Byron On, who's working on the interaction of prosody and syntax, two different domains that interact with each other.
mhm.
I have a friend, Shannon Bryant, she's working at the intersection of syntax and semantics. And it's like the line gets very fuzzy between these divisions. You know, you mentioned these five divisions. How separate are they? I think of my old
Mhm.
uh, the chair of the department at my old university in Delaware, Ben Bruning, works on um, a thing he calls preceding command, so like linear ordering in language, because the Chomskyan paradigm is very adamant that like linear ordering doesn't matter, but
Mhm.
what really matters is hierarchical structure. And Ben Bruning is looking for evidence in language. Say, well, no, actually, linear order does matter some of the time, and so this would be a thing that the model can't quite account for. Might have to revise the model. And there are other things that I think we're going to have to contend with in the future if we think about moving into the future. I think at some point we're going to have to contend um, with grammaticality as a concept, and ask what it is we're measuring when we get grammaticality judgments. What is it that generates those? And I think that there is a certain amount of linguistics that's moving in the direction of imagining models that are much more gradient and less discrete, because our judgments are very gradient. And I think about the work that Shannon Bryant is doing, where there are like very odd things that can affect grammaticality judgments that you would think from a old school Chomsky syntax perspective, like that stuff shouldn't matter, but it does. So I think we're going to have to figure out how to make a model that can incorporate all these facts at some point. But that's job for somebody else. I don't want to do that.
Mhm. Now we can talk on the questions in your research fields now.
Sure.
Language processing involves complex mental competitions. What are the competitions the mind performs with respect to language? With these questions, I aim to learn the briefly explored specific cognitive process that underlie language composition and production. Can you explain briefly?
So $1 million question, right? We don't we don't know. So we don't have a full accounting of what all
Mhm,
of the computations are. We don't know. This is why
mhm,
it's a research area, right? Is
mhm,
because we don't
mhm,
know. But I think we're moving in a productive direction, because I think of
mhm,
people like Thomas Graf. He recently wrote a paper, a long form article for the journal Theoretical Linguistics, and he made this interesting argument. Basically, we're taking tools developed by Noam Chomsky in the 50s, which linguists have not paid a lot of attention to, I think, in the time since then. But computer scientists have really developed in that time. These tools turned out to be very useful for computer science. The tools of formal grammars. So thinking about language in terms of formal grammars, which was originally how
mhm,
Chomsky thought about language, taking how that, the way in which that's been developed by computer scientists and mathematicians, and reapplying it to language. Thomas Graf is making a really interesting argument where he says, like, actually, I think that the computations involved in language are a lot simpler than we have assumed for a long time. If you get the right kind of representations and you feed that into this formalism, then you can really strip down the complexity of the set of computations. But the question of what are the computations is like, oh man, it varies from language to language. It
mhm,
varies across different
mhm,
areas of
mhm,
language. Um, right now, we're focusing a lot on phonology because it's something that we know a lot about. The models seem to work really well, and it's pretty tractable. So, in my lab, we're thinking about the difference between local and non-local or local and long distance phonological rules. There are some rules where it's like, you can only have certain sounds go next to each other. English has a lot of rules like this. You can't have just like any two random consonants in a row. Can't have a word that starts with huh. Um, that's not very good for English. All languages have rules like this, but some languages, which you will be familiar with, like, because Turkish is one of them, some languages have rules about phonology that are non-local, that are long distance. So, like in Turkish, you have rules about what kinds of vowels can be in a word, and the vowels have to kind of match in some
Exactly.
way. Right? It's this vowel harmony. So we're actually studying vowel harmony. We have a study that we're going to run this summer using fMRI actually to look at people learning vowel harmony versus rules versus other kinds of rules and see where the brain activation is for that.
Okay. And finally, questions on mentoring gifts for mentoring gifts. High school students often require resources that are tailored to their burgeoning interest in a specific academic, especially for gifted learners. What are the popular science book, introductory level textbooks, and YouTube channels, etc., that you can recommend for high school students in high school level who are interested in your field of study?
Textbooks are tough because I don't know how accessible they are in terms of, well, one, like financially, textbooks are usually pretty expensive, and and you can't usually buy them at a bookstore. I got lucky when I was in high school. I found an old linguistics textbook, and that's how I got into linguistics. The other thing that really got me into linguistics when I was in high school is I borrowed a copy of some DVDs from my German teacher. She just happened to have this set of, I think it was the Great American Courses on Linguistics by John McWhorter. And it was great. It was just like it was like an introductory course on linguistics in DVD format. These kinds of things, I think you can maybe find at a local library. They sometimes have these kinds of things, like these DVDs. But YouTube is always there. If you're interested in linguistics, there's a great introductory linguistics YouTube channel called The Ling Space. That one is really good if you're interested in linguistics. I have two YouTube channels. So I have a
Especially
YouTube channel.
I will mention the explanation in this video.
Yeah, so I have a YouTube channel that has a lot of lecture videos. That's basically my intro course on CogSci. I have another one where I do more kind of fun stuff about language and cognition. There's, yeah, those are kind of like introductory level things that immediately come to mind. And there are some good books. The thing is, like with popular books on language and cognitive science, I can think of lots of books on like specific topics, but it's hard to think of good books that just introduce the field in general, especially CogSci. I don't know that I found a really good popular science book that just introduces cognitive science. Maybe it exists, but I haven't seen it.
As students progress to university, their academic needs evolve, requiring more specialized and advanced resources. What are the textbooks and research and blogs, etc., you can recommend for undergrad students who are curious about your field of study?
Yeah, so I actually have a lot I can recommend here. There are some really good linguistics blogs. I think the best is there's a blog called Faculty of Language, which is maintained by Norbert Hornstein. He's a very famous syntactician. There's also Language Blog, which is good. I think Thomas Graf might have a blog. I think it's called Outdex. There's some other in CogSci more broadly. There's Hetham Alagpour has a good blog. He does a lot of kind of biological computation stuff, which is really, really interesting. And Adam Mastroianni has a fantastic blog. He's a psychologist, and his blog is partly it's about psychology and like social psychology is kind of what he was studying, but partly it's also just about academia and what it's like to be an academic. And I think that that's really illuminating for people who are not in academia. There's a really great podcast called Neuroscience of Language. I think it's called Neuroscience of Language. I can send you a link, put it in the description. And that's hosted by some neurolinguists, and they just invite other neurolinguists to come on and talk about their research. So that's a really great resource for people who are interested in like this kind of specific topic area.
Okay. Our last question. Considering a career in academia requires not only knowledge, but also specific skills and qualities. Finally, as an assistant teaching professor, What basic skills and conceptual qualities should those constrict an academic career in your field have in order to do notable study in this field?
I think this is a really great question that people don't often ask.
Mhm,
And I read a really great article a couple years ago by a math professor, and it was all about how the students, the incoming PhD students in
mhm,
mathematics,
mhm.
often don't realize what is entailed in doing a math PhD and in being a mathematician, as opposed to like doing math. Like we do math on a daily basis, but like being a mathematician at that level is actually a very, very different animal. It's a very different skill set, and it requires a very different disposition than people are used to. So students who are good at doing math, they're good at learning math. They think, oh, I'm good at this. I know all the formulas. I know how to do. I know how to do all the stuff I'm supposed to do. Maybe I should go to grad school. They go to grad school, and
Mhm,
according to this mathematician said, there's sort of a rude awakening when they realize
mhm.
that like that's not actually what being a mathematician is like. So I think that this is a real thing that happens. We go to grad school sometimes because we're good at school, but to be a good researcher, that's not the same skill set as being good at school. Being a good researcher, I think what people underestimate is it requires first and foremost a lot of creativity. That's functionally the most important attribute you can have as a researcher is the creativity required to come up with a research idea, to have insights about research. So yeah,
Mhm.
you have to know a lot, and yeah, you have to be a strong writer. You have to have writing skills. You have to have data analysis skills. These are all acquirable skill sets. But you have to also have a certain kind of disposition. You just have to really be into it. You have to have
Mhm.
like this intrinsic love of whatever the
Exactly,
topic is,
exactly.
and you have to have a lot of creativity and you have to have a lot of stamina. And
Mhm,
I know a lot of people that go to grad school and a
mhm,
lot of people who went to grad school, and at some point they realize like, wow, I hate this. Like, I
mhm.
don't want to do this at all. And you have to give yourself the leeway to say, like, you know what, this isn't for me, and I got to leave. Because a certain amount of it is about your personality and your disposition. I think to a certain extent, academics are very weird. They're weird people. They're just like really like whatever this is.
You
And
are
if you get there and you find that that's not you, and you would rather do something like if you say, I would rather help people, this is going to sound bad, but like, yeah, I don't know that academia is really a great place if you
mhm.
want to you want to help people. We're here just because we're like sort of curious about things. And um,
Exactly.
I like teaching. I guess I feel like I help
Mhm,
people teaching,
mhm.
but like, some people are really motivated and say, man, I want to heal people. Like, well, you're not going to necessarily do that in academia. You should probably be a doctor.
Exactly. Dr. Ross, is there anything you would you like to add? I can take them as well.
um, yeah, I don't know if I have anything in particular I want to add. This was fun. I'm glad I sat down to do this. Um, your YouTube channel is focused on gifted children,
Yes, gifted.
and I'm not an expert in that domain. I don't know.
Mhm,
I didn't study education or anything,
mhm.
but it is important to get kids the
Exactly.
opportunities for this kind of stuff. I think the thing I would want to say about gifted children is there is some pushback, I think, publicly against having specialized gifted programs.
Exactly.
I think because they feel kind of elitist or something. But I think I always think about Stephen Jay Gould, and Stephen Jay
Mhm,
Gould was really adamant about this idea that
mhm.
there's talent everywhere, and there are a lot of people right now, and I think a lot of children who are languishing, um, in other countries, but
Mhm,
also
mhm.
also in wherever you are, there will be children who are in a community that has less resources than yours or
Exactly.
whatever that they get left behind. There may be like tremendous amounts of talent, and intellect, and curiosity and creativity. It's all hiding right there. If only we could get the resources to them. So I think that moving away from gifted education is probably a mistake. But what we should do is maybe find a way to make it more accessible and more broad and cast a wider net, right?
Exactly.
And the other thing is, I know I mentioned creativity, but I think especially for gifted education, I think creativity's got to be like number one. There's too much of, I hear too much from people about how going through an educational system really stifled their creativity.
Uh-huh.
I think like what a loss. That is such a loss to lose the
Exactly.
creative potential of human beings. Um, and yeah, the only thing I was gonna say is that when I was, thinking about, you know, your the questions you were gonna ask here, um, I watch a lot of YouTube videos too. I watch a lot of YouTube videos about film analysis and stuff because I find it interesting. And something that worries me a little bit, sort of speaking on the level of creativity and cultivating creativity, I am sometimes a little bit worried by what I observe about sort of media literacy
Exactly.
broadly, sort of in public. I think that maybe we are not doing enough to cultivate not just curiosity and creativity among children, but also a kind of a way of interacting with media that's sort of more critical, more um, engaging with narrative in a critical way, engaging with things like stories and literature and film in a creative and critical way. I think that gifted education sometimes can be very good about that. But maybe the lesson should be that we should import some of those things to general education.
Exactly. So this is your motto, cultivate curiosity.
Yeah, that's my thing. Yeah, it's like if I have to describe my personality in one word, I think that's it. I'm just very curious. And people say that about me. It's like just an innately curious person. And I have been since I was a kid. That's why I push this as I like I think that if you're going to do gifted education, it should be about cultivating curiosity. And that's why I don't worry much about skill acquisition. Sometimes people get very fixated on we need to make sure kids get the right skills. I think no, you need to make sure kids get the right disposition. If they have the right disposition, they will get the skills themselves. And I see that in my students. My students are very good, and often they will go and they'll learn things on their own. They'll get the skills on their own, and they can come to you and say, "Oh, how can you help me with this?" And I'll help you. But I don't think that we should lean into an education model that is fundamentally about dumping skills into children because that's not the point. The point is to develop a child into a kind of person that can develop their own skills, that understands like what's important and has a disposition and attitude to want to acquire skills. A kid who wants to learn things.
Exactly. Thank you very much, Dr. Rhodes, for coming and contributing our YouTube channel, Aristotle Learning, once again.
No
If,
problem.
if so, this is all of the interview with precious neurolinguist Ryan Rhodes from Rutgers University Center for Cognitive Science, New Jersey. Thanks for watching and give me a like. See you soon for future videos.